Hello Group 1 aspirants, welcome to TSAT. Today we are going to learn about space technology in Science and Technology paper. So what we are going to learn today, in this session we are going to learn about satellites, natural satellites, artificial satellites. We will also learn about orbital definition, types of orbitals based on the function and altitude, the launch vehicle of India, and why do we use these launch vehicles. We will also learn about why do we have different stages of launch vehicles. So India's types of launch vehicles, we will also learn about the applications of space technology. We will talk about the present satellite systems, and also we will talk about the past major technological and applications and advancements in science and technology, especially in space technology. And also we will talk about the future missions of ISRO, and in the end we will also talk few questions. So what is a natural satellite? A natural satellite is an astronomical object orbiting the Earth or any other planet. As like we all know that the moon is the only natural satellite of the Earth. Some other planets in the solar system have more than one natural satellites. So we all know that the Earth have one satellite, that is moon. This moon revolves around the Earth in a particular path. So similarly, if we have man-made objects revolves around the Earth or any other planet in a fixed orbit, then it is called artificial satellite. So artificial satellites are man-made objects which revolves around the Earth or any other astronomical object. So these satellites travel along a particular path around a space object. So the path traversed by the satellite is called orbit. So orbit is nothing but the path traversed by this natural or artificial satellite is called orbit. So you can see in this image, there is one artificial satellite is revolving around this Earth. So this path is called orbit. So all artificial satellites do not revolve in similar orbits around the Earth. So the Earth having a different types of orbits. So the functions of the satellite decides the height of the satellite's orbit from the Earth's surface. The nature of the orbit, it may be circular or it may be elliptical, and whether the orbit shall be parallel to the equator or making some angle with it. So all these things will be decided by the functions of the satellite that we are intended to perform. If you look at this image, one orbital here is in a different height from this space to this, and if you look at this has got a different height. So based on this height, these heights are decided by the function that this satellite is going to perform. You can all see that there are certain orbits which are very near to Earth, there are little far away from the orbit, and there are certain things which are very far away from the satellite. So to put the satellites in its proper orbit at a specific height above the Earth's surface, the satellite is taken to that height using a satellite launcher. So if we want to keep the satellite on a particular object in a particular orbit, so we have to take that to a particular height, and then we have to keep that satellite in this particular orbit. So in order to do that, what we will be using is, we will be using a satellite launcher. Satellite launcher is something like a car that will take us from one place to another place. Like that, the launcher will also take the satellite and keep this there, and it will come back or we will be destroying that launcher there itself. Now let us look into a satellite is a given. We all know that the satellite has to move around the Earth or any other object. If it wants to move around Earth, then the satellite should be given a specific velocity, and that velocity is known as a critical velocity in a tangential direction to the orbit. If this satellite wants to revolve around this particular orbit, then we will be given a specific velocity, and that velocity is called a critical velocity. And critical velocity is the velocity required to keep that satellite in that particular orbit. So orbits are of various types. So let us try to understand a few important types of orbits based on the functions of the orbit. So we all know that the geosynchronous orbit, geostationary orbit, sun synchronous orbit, and polar satellites. So these are the orbits, types of orbits based on the function that they would perform. So what is geosynchronous orbit? A geosynchronous orbit is an orbit that around the Earth of a satellite with an orbital period equals to the Earth's period of 23 hours, 56 minutes and 4 seconds. So it is a low inclination orbit. Low inclination means if you see this here, it is actually it is making some angle here, and this angle is a very low angle. So that is why it is called a low inclination orbit. So geosynchronous orbit means an orbit that revolves around the Earth. The time period of that satellite is equal to the time period of the Earth. That is why it is called geosynchronous orbit. Geosynchronous means, geo means Earth, synchronous means it is in sync with the time period of the Earth. That is why it is called geosynchronous orbit. So this geosynchronous orbit, a spacecraft in a geosynchronous orbit appears to remain above the Earth at a constant longitude. Although it may seem to wander north and south, but since this satellite is having the same time period of the Earth's time period, so it looks like a constant on a particular longitude. So the spacecraft returns to the same point in the sky at the same time each day, because this Earth revolves around on its own axis, and the satellite is also moving around the Earth's axis, and both these have the same time periods. Time period means the period, that is the time required to move from this place to come again from the same place in a 360 degrees. So that is called a time period. So the time period required to complete one full circle or complete one full cycle is called a time period. So when Earth and orbit satellite will have the same time period, then it obviously it would act like, it would look like a constant if you look at the satellite from the Earth. So what is geostationary orbit? So geostationary orbit is nothing but it is a special type of geosynchronous orbit. So as any geosynchronous orbit that is a circular in shape and it is exactly above the equatorial line is called geostationary orbit. Since it is geosynchronous, the time period is 23 hours, 56 minutes and 4 seconds. If you look at this picture here, we have two types of orbits are there. One is this one and another is this one. In these two equations, both might have same time periods, but both are not geostationary orbits. This red colored one is the geostationary orbit. It is geostationary orbit because it is satisfying two more conditions that is, the orbit is circular in nature, in shape, and it is exactly above the equatorial line. So that's the reason why this is called geostationary orbit. So in order to be a geostationary orbit, it should satisfy three conditions. One condition is as a time period, that is, it should have the time period that is equal to the Earth's time period, and then it should be above the equatorial line, and the orbit should be circular in shape. So these are the three conditions that we must remember it should satisfy to be a geostationary orbit. Since it is a geosynchronous, the time period is, we all know that we have said that, the 23 hours, 56 minutes and 4 seconds. So this orbit is ideal for certain kinds of communication satellites or meteorological satellites. So if we want to have communication, so the satellite will actually take the signal from the Earth and then it will send the signal to the Earth again. So if we want this sort of function, it should have a constant from the Earth. So if one could see this satellite in the geostationary orbit, it would appear to remain constant in one place in the sky. So at whatever the time you look at that satellite, it would actually remain constant. Since it is remain constant, it is easy to send signals and it is also easy to receive signals from a particular place, from a particular region. So for that reason, we use this orbit for satellites that are used in telecommunication. So simply we can tell that for telecommunication we will use geostationary orbit. So what is a polar orbits? Polar orbits are nothing but these orbits that actually pass over the Earth's polar regions from the north to south. From the north to south, it actually revolves around the Earth. The orbital track of the satellite doesn't have to cross the poles exactly for an orbit to be called polar. It may have some sort of an angle also. It may have some sort of an angle also. So any orbit which passes within 30 degrees, within 20 to 30 degrees, then it is called a polar orbit. So this polar orbit is an orbit that revolves around the Earth from north to south within this angle of 20 to 30 degrees, also called polar orbits. So these orbits mainly takes place at low altitudes of between 200 to 1000 kilometers. The satellites in polar orbit look down on the Earth's entire surface and can pass over the north and south poles several times a day. Which means if an artificial satellite having a polar orbit which actually passes the Earth several times in a day. So the polar orbits are used for reconnaissance and Earth's observation. Since these satellites in the polar orbit actually revolves around the Earth from north to south, so these are used for reconnaissance and Earth's observation. If you want to observe the Earth several times in a day, we will be using these low Earth orbits that revolves in polar satellite orbits. If a satellite is in a polar orbit at an altitude of 800 kilometers, it will be traveling at a speed of approximately 7.5 kilometers per second. So what is a sun synchronous orbit? So this orbit is a special case of the polar orbit. So these are polar orbits which are synchronous with the sun. This means that they are synchronized to always be in the same fixed position relative to the sun. So, it is relative to the sun, these satellites are a fixed position, they are in the fixed position. So, this satellite travels from the north to south poles at the earth turns below it. So, the satellites travel from north to south poles as the earth turns below it. The satellite passes over the same part of the earth at roughly the same local time each day. So, it means if a polar satellite, especially the sun synchronous satellite, is revolving around the earth, if that satellite comes on Hyderabad at 2:30 p.m., then every day at 2:30 p.m. it exactly comes above the Hyderabad itself. So, in order to, if you want to observe this Hyderabad every day at a particular time, then we will be using the sun synchronous orbits. So, if we have a function to observe a place at a particular time, then we will be using this sun synchronous orbits. So, a satellite in a sun synchronous orbit would usually be at an altitude between 600 to 800 kilometers. Generally, these orbits are used for Earth's observation, solar study, weather forecasting and reconnaissance. As the ground observation is improved if the surface is always illuminated by the sun at the same angle when viewed from the satellite. So, if we want to observe a place on the earth, we need to have a sunlight. Since it is coming on the regular time, so we will ensure that the place that we are going to observe is enough lit by the sun. So, that is the reason why we will be using sun synchronous orbits, polar orbits, if we want to observe the earth. So, it is not only observation of the earth, if you want to forecasting the weather and reconnaissance. Reconnaissance means if we want to observe the terrorist activities in the border of India-Pakistan, if we want to observe that, we will be using these polar satellites or sun synchronous satellites. So, because we want to observe a particular place at a particular time every day. So, that is the reason why we will be using these polar satellites for reconnaissance. So, we have talked about sun synchronous orbit, polar satellites, and now let us move on to another types of orbits. These orbits are basically low Earth orbits, medium Earth orbit and high Earth orbits. So, they are nothing but there are different types of orbits, but these orbits are categorized based on the height of the orbits from the Earth. A low Earth orbit is nothing but, as the name itself suggests, any orbit that is relatively close to the Earth's surface, then it is called low Earth orbit. It is normally at an altitude of less than 1000 kilometers, but it could be as low as 160 kilometers above the Earth. And if you look at this here, from here, the height of this, it would be anywhere between 160 to 1000 kilometers. So, any orbit that is between 160 to 1000 kilometers from the Earth, then we call that orbit as low Earth orbit. So, which is very low compared to other orbits, but this 160 is not very very low. It is actually very high. The planes would actually go in between 11 to 15 kilometers like that. So, the satellite in this orbit travel at a speed of around 7.8 kilometers per second. At this speed, a satellite takes approximately 90 minutes to circle the Earth, meaning the sun synchronous orbit that we were talking about travels around the earth 16 times a day. 16 times a day, which means if we want to observe the Hyderabad or if we want to observe the India-Pakistan border, then if we use this sun synchronous orbit that is a low earth orbit, it would actually revolves and it will always sees that India-Pakistan border 16 times a day. So that is the reason why for reconnaissance we are using this low earth orbit in a sun synchronous orbits. However, these LEO satellites are less useful for tasks such as telecommunications, because they move so fast across the sky and therefore they require a lot of effort to track from the ground stations. So if you want to send signals and receive the signals from us simultaneously, constantly for telecommunication purposes, this is actually not suitable. So now let us talk about high Earth orbit. A high Earth orbit is a geocentric orbit with an altitude entirely above that of a geosynchronous orbit, that is 35,786 kilometers. So any satellite above this 35,786 is called high Earth orbit. So the orbital periods of such orbits are greater than 24 hours. So greater than 24 hours, if you look at this here, the GEO, this orbit is having around 35,786 kilometers from the Earth. Now we have talked about LEO, that is low Earth orbit. Now we have talked about high Earth orbit. So then what is this medium Earth orbit comprises? So it is a wide range of orbit anywhere between this LEO and GEO. Then we call this as a medium Earth orbit. It is similar to LEO in that it also doesn't need to take specific paths around the Earth, and it is used by a variety of satellites with many different applications. It is very commonly used by navigation satellites. If we want to use a satellite for helping the navigation means it may be ships, it may be aeroplanes, we will be using this medium Earth orbit. So now let us learn about the transfer orbits and geostationary transfer orbits. So these don't come into the categories of the category based on the function or based on the altitude, but these are special types of orbits. We'll actually use this for a different purpose. I'll tell you how it is going to, why we are calling this transfer orbits. So these transfer orbits are a special kind of orbit used to get from one orbit to another orbit. Suppose you look at this picture here. If we want to send a satellite here, we want to send a satellite in this position. If we want to keep a satellite here, but the Earth is here, and what we need to do is we need to send the satellite around this. And what we will be doing is, initially we will be taking this satellite up to this position first, and then it revolves around this. And when it comes this position, we will actually change the velocity of the satellite and we will increase the speed. Once we increase the speed, what happens? It actually goes to a different orbit. So this orbit is called a transfer orbit. Because this orbit is used for transferring from one orbit to another orbit, that is the reason why we call this as a transfer orbits. So transfer orbits are what? Transfer orbits are orbits that is in between the two orbits. So, when satellites are launched from the Earth and carried to space, the satellites are not always placed directly on their final orbit. You cannot keep an orbit directly here itself because of many technical issues, because we may not have that much power to send a satellite from here to here. That's the reason why we need to use a different technique to send it from one place to another place, and from there you increase the speed, then you take it to a different level. Like that, we will actually use these transfer orbits from one place to another to keep it from one orbit to another orbit. So there's often the satellites are instead placed on the transfer orbit, that is an orbit where by using relatively little energy from built-in motors, the satellites or spacecraft can move from one orbit to another orbit. For instance, we have used this technique in Mars orbiter mission. In the Mars orbital mission, what we have done is we have actually taken this, you imagine this is a Earth, and what we have done is this is a Mars. So Earth's influence is somewhere up to here. So if you want to send a satellite beyond the influence of the Earth, and then if it goes near this Mars, then what happens? The satellite actually comes in the vicinity of in the influence of this Mars, and it will revolve around the Mars. Since we have the power, that energy that required to take this escape velocity, that is VC, it's not that easy to achieve. For that, what we have done is, since we have our launches are not good enough, powerful enough to send this, what we have done is initially we have taken that satellite here, let us take up to here, and then what we have done is when it came to this place, then we increase the power, then it reached another level. From there again we have given another level, then it reached something like this. When it came here, and then what we have done is we have given another booster, and then when it given another booster, it came under the influence of the Mars. Once it came under the influence of the Mars, then it would start revolving around the Mars. So once it revolves around the Mars, based on the speed it can actually this speed will decide whether the height of this satellite from the Mars. So like that, we have used this technique of transfer orbits in order to send a satellite to the Mars. The satellite launch vehicles are used to place the satellites in their specific orbits. We have learned this. The functioning of the satellite launch vehicle is based on the Newton's third law of motion. So we all know that the Newton's third law, that is, for every force there is an equal and opposite force. So the launch vehicle uses a specific type of fuel, that is, the gas produced due to combustion of the fuel expands due to its high temperature and is expelled forcefully through the nozzle at a rear side of the launch vehicle. Today, in this session, we have learned about the natural satellites, artificial satellites. We have learned about defining the orbits, and we have also talked about various types of orbits based on the function and based on the altitude also. Based on the functions, we have learned that the orbits are of different types, like geosynchronous orbit, geostationary orbit, polar satellites, sun synchronous orbits. And based on the altitude, we have learned about LEO, that is low Earth orbits, and we also learned about high Earth orbits, and we have learned about MEO, that is a medium Earth orbits. So apart from these two, we have also talked about transfer orbits and geostationary transfer orbit. So these are special types of orbits. So this is the session, and the remaining will talk out in the next session. Thank you.